NVIDIA graphics processing units, like these latest Blackwell GPUs, are inside server racks all over the world. NVIDIA has catapulted from gaming giant to the very core of generative AI, training the models, running the workloads, and sending NVIDIA's valuation soaring, with 6 million Blackwell GPUs shipped over the last year.
This connects all 72 GPUs, allowing them to act as a single GPU to power the most advanced AI workloads.
GPUs are the general-purpose workhorse stars of NVIDIA and its top competitor, AMD. But another big category of AI chip is gaining ground, the custom ASIC, application-specific integrated circuit, now being designed by all the major hyperscalers: Google, Amazon, Meta, Microsoft, OpenAI, alongside Broadcom. These AI chips are smaller, cheaper, accessible, and, as the name suggests, specifically built for one purpose.
But we see that growing even faster than the GPU market over the next few years.
AI chips also include FPGAs, field programmable gate arrays, and an entire group of chips used to power edge AI on device instead of in the cloud. In short, there's a lot of AI chips, and the space is only getting more crowded. So let's take a pause to break it all down. The various categories of AI chips, what's different, good, and bad about them each, and a brief look at all the major companies getting in on the AI chip-making trend. Google was the first to make a custom ASIC for AI acceleration, coining the term Tensor Processing Unit when its first ASIC came out in 2015. The TPU also helped lead to the invention of the Transformer at Google in 2017, the architecture powering almost all modern AI. We got a tour at Google's Chip Lab in 2024.
There's actually 4 chips inside there. It's connected, actually 2 of those are connected to a host machine that has CPUs in it. And then all these colorful cables are actually linking together all of the Trillium chips to work as one large supercomputer.
A decade after the first TPU, Google just released Ironwood, its 7th generation, and with it a big deal with Anthropic to train its LLM Claude on up to 1 million TPUs.
Some people even think that they're technically on par or even superior to NVIDIA, but traditionally Google has only used them for in-house purposes. There's a lot of speculation that in the longer run, Google might open up access to TPUs more broadly.
Amazon Web Services was the next cloud provider to design its own AI chips, after acquiring Israeli chip startup Annapurna Labs in 2015, where Ron Diamant has worked since day one. AWS announced Inferentia in 2018 and launched Trainium in 2022, now approaching its 3rd generation. Think of Trainium like a cluster of workshops with many small, flexible tensor engines, while Google's TPU is like one big factory conveyor belt with one big rigid grid specialized for matrix math.
Physical AI and leverage all these other capabilities that help advance, a lot of the manufacturing that will be coming back here to make sure that the U.S. stays globally competitive.
Huawei, ByteDance, and Alibaba are some major Chinese players making custom ASICs, although they are limited by export controls on the most advanced equipment and AI chips, like NVIDIA's Blackwell. The other big differentiator will be who can secure enough power for all this huge AI data center build-out.
If the U.S. wants to continue to lead in AI, we continue to be fraught with energy risk. China's done that much better than us, for instance, and while we do have the best chips in the world, and I believe so by multiple generations, I believe that our need to build out energy is critical.
But with NVIDIA's lead as the most valuable company in the world, companies are not slowing down in the race to make their own AI chips. Although dethroning NVIDIA won't come easily.
They have that position because they've earned it and they've spent the years building it and they've won that developer ecosystem. But that market's going to get so big that we're going to continue to see new entrants.